Saxon Algebra 2, Lesson 72. 2 parts. The second topic is more fun than the first topic, so that's something to look forward to. I know, you're welcome. Lesson 72 is a blessing and a curse. The topic is lines from experimental data, and I see your face. As soon as I say experimental data, you're like, oh dear God, deliver me from this nightmare. I know, but it's gonna get kind of better. Let me show you what we're doing in this chapter of Adventures with Scientific Data. Here's our experiment. We took carbon and we somehow turned it into salt. I don't know. I can't tell you about that. But this time, the scientists have plotted the results of their experiment on here. Ignore the A and B, that's not important right now. And they're asking us, because we're the mathematicians, we're the brains of this operation. No offense, scientists, you're cool too. But they're asking us to come up with the numbers, to see if there's a line that goes through this data, to come up with the equation of that line. And so they didn't draw the line ahead of time, they left it to us. Now, John says something profound here. There is never an exact answer to these problems. There's the curse. The blessing is we get to draw our own line. The curse is there's never an exact answer. So students get really frustrated. Did I do it right or didn't I? I'm sorry. These experimental data points are often scattered and we can only estimate the position of the line. So what John's doing here, and I'll use my piece of paper to show you, is he's saying given the way these points are distributed, one could easily draw line A. See how line A kind of goes through the middle of most of them? But a scientist could also draw line B, right? They're kind of together here and then they seem to sort of converge into 2 prongs. I would argue that the best line might be line C that kind of goes in between A and B, right? That goes along there and then through the middle of all of those points. That's kind of a question for the scientist to resolve. But the good news is the scientists are letting us draw the point. So what that means, and John does not do it, but we're going to do it. We always choose to begin our line on a perfect corner of the grid, and we end our line on the perfect corner of the grid. Now, sadly, in this case, John began one in the middle, ended that one in the corner. Then the other one he began on the corner, but he ended it in the middle. So John doesn't know how to make life easy on himself. What we're going to do is when we draw the line, we're going to make sure it goes specifically from exact corner to exact corner. Then we have 2 beautiful, clear points to use. And there's no drama in doing these problems. Well, I'm sorry, there is drama because when we go to the answer, it's probably not going to be exactly the same as ours. It should be close, and I'll talk about that when we get further in. But you're not going to have that satisfaction of click, there it is. All right, actually there isn't an example from this problem, so that's sad. But John shows that for his line A, remember how he drew the A and the B? Well, when he took the points and calculated the slope and then plugged them in, this is the equation he got. 0.1125c minus 5.5. For his other line, line B, when he pushed that through, it got 0.075c. So look how different that is. That's quite different. And look how different his y-intercept is from negative 5.75 to negative 3. This is where the headache comes in. If your line is different from John's, it's not going to feel very close. You could have a difference like this. Ay, ay, ay. So it says your answers to problems like these in the problem sets should be approximately the same as the answers given in the back of the book or the solutions manual. However, they will almost never be exactly the same as the answers. Oh, that's frustrating. But the good news is you get to choose, you get to draw your own line, and so you can pick perfect points, and at least you don't have to rip your hair out trying to come up with points to use. So here's the moral of the story. Begin and end your line at perfect points. And by that I mean on the corners of the graph paper, right? So that you know exactly the precise values of the x and y coordinate. All right. If you are frustrated with your answers on these, reach out to me and ask me if it's close enough. You guys in general tend to be kind of a non-ASCII group. You guys don't ask me a lot of questions. Most of my other students ask a lot more questions than you guys do, which I don't evaluate. I mean, that's just the way it is, right? But if there's anything you are ever going to ask me a question on, these are the questions you should be asking me about. These problems are drama and it's very hard to interpret. So please do not be shy. Ask me. Okay? Send me your line. Tell me the points you used and ask me if that's a close enough answer. Okay, B. That's a very unsatisfying topic, isn't it? B is much more fun. Negative angles. What, you say? Negative angles. Now, they don't have bad attitudes. They're not pessimists, but they are negative in a different way. Normally, and this refers to polar coordinates, by the way. Normally, we would see something like this, right? We know that we start here at our x-axis, and we start to measure going around this way, right? And we'd go 90, 80, 180, 270 is too far. From 180, we only need 30 more. And this is our total of 210 degrees, right? That's the way we've been doing it. And then we would measure our hypotenuse out, and we'd say that's 4. The length of the hypotenuse is 4. But look what I'm going to do. One tiny little mark from my red pen, and suddenly a nightmare unfolds. Just kidding. It's not a nightmare, you guys. It's not that bad. It's going to be fun. What this minus sign tells us to do is don't go this way, go this way. Oh, okay. So what I'm going to do, I'm just going to draw a fresh one so that we're not drawing pictures on top of pictures. So this time I'm going to measure my 210 the very same way, except I'm just going to go in the opposite direction. So here's 90. Here's 180. Now I need 30 more to get my full 210 degrees. Do you see how I did that? The rest is the same. This is 4, that's my hypotenuse. This angle is still a 30-degree angle. So now the negative sign has gone away, and everything else I do from here on out is the same, all right? This minus sign just drives how I find my triangle. It doesn't change what happens once I get there. So now I'm trying to find the rectangular coordinates for this, right? So I know that it's going to be hypotenuse times the cosine of 30 degrees. That will give me my R value, and my up value will be 4 times the sine of 30 degrees. I use my calculator / look in the book because John has the answers for us. The sine value is 2, and the cosine value is 3.46. Now I know it's going to be a negative right? This is going to be negative, so I'm going to write negative 3.46 to the right, but then I'm going to go up for the positive, right? Because my point's right there. So it's negative right, positive up, plus 2 up, and that is my jolly little answer. Not bad, right? Like I said, once you measure in the opposite direction, widdershins, that's what I always want to call this. Negative angles are widdershins because it's like it's going in the wrong direction, right? What is widdershins? It's the way the toilet bowls swirl in Australia. That's all I can think of. It's when something spins in the opposite direction. One could say clockwise, but that would make this counterclockwise, and that just doesn't feel good to me. I prefer to think of negative angles as widdershins. And there's the right answer. Is there another problem? No, we're done with lesson 72. Yay. I'm sorry to say. Oh, you don't have, no, I don't know if you guys are doing A and B. I really want you to do always, all the practice, odds on the problem set. Okay, I don't know if that's what you're doing, but that's what I want you to do because I always want you to get all of the practice of the new ideas as possible. So if you haven't been doing it, you don't have to go back. But from here on out, please make sure you always do all of the practice and odds specifically on the problem set. I don't want you going back and forth between odds and evens. Don't do that. Just do odds always down here and all of the practice. Okay, don't forget to memorize your quadratic formula for the review problem today. Not today, this week. And that is all. Goodbye.